This video is to help with some of the homework problems on section 10.5, page 646. The numbers were these. Oops, 27. Okay, and I just picked out a few to do to help because these problems are not easy. All right, number one was a picture of a regular hexagon. It doesn't look exactly like this, so y'all forgive my drawing. This radius was 4 meters. Okay, so the first thing I always do is write down the formula. Area equals 1/2 times perimeter times apothem. Now here's the problem with this one. We don't have a side. If we had a side, we could just multiply it by 6 to get the perimeter. So I don't have that. And we don't have this apothem. So this is one of the hardest types of problems. If they give you radius, you've got a whole lot to be able to find before you can even go to this formula. So the first thing I do is I draw this triangle right here, and I put in the apothem because I'm going to need that. So I'm going to draw that little half triangle right here. The reason you want to draw this little half triangle is because it's a right triangle, and then we can use all those rules that we learned in chapter 8 to find missing parts of right triangles. So I draw this little half triangle. This is 4 meters. Okay, I need both things. I need this apothem, and I need this little half of a side right here, so that I can get how long a whole side is. I'm going to call that x. And I don't have enough information right now to be able to find a and x, so I need an angle. And that's why we talked about angles of these triangles. So this whole angle right here, the central angle, is 360 divided by how many of these angles there are. And there are 1, 2, 3, 4, 5, 6 of them, the same as the number of sides. It'll always be the same as the number of sides. So that is 60 degrees. That's this whole central angle. When you draw in the apothem, it split that 60 degrees into 30 and 30. So this angle is 30. Okay, now we've got ourselves a 30, 60, 90 right triangle. And from chapter 8, across from the 30 is A. The longer leg would be across from 60. You could write that 60-degree angle there if you want to, but that would have to be a 60. Across from that is A radical 3, and across from the 90 is twice A. So here's what we've got. We've got twice A is 4. So that means plane old A is 2. If twice A is 4, then plane A is 2. That's how long this is. And then this side would be that A number times a radical 3. So this is 2 radical 3. I used A for apothem, but it might be better to pick a different variable because you might get it confused with these A's. So maybe I should have called the apothem Y just to not get it confused with these. Anyway, I've got all the information I need now. See, this little half side right here is 2. That's this. So the whole side is 4. And that's going to happen on hexagons only. We'll have a radius equal to a side. That's always going to happen because it's A and twice A. And so when you double this, you get the same thing as twice A. Anyway, in a hexagon, these will be the same. So now I can get the perimeter because one side is 4, and 4 times 6, because there's 6 of them, that's 24. And the apothem is this measure that I found right here, which come down here, it's 2 radical 3. So now I've got all the things in my formula that I need to multiply. So multiplying, half of 24 is 12, and 12 times 2 is 24, so it's 24 radical 3. Or you may have noticed this, that this half times this 2, basically they canceled because half of 2 is 1. So you may have noticed that. The answer is 24 radical 3 meters squared because this is area. So that is how to do number 1. That is not an easy problem. There are just lots of parts to it. So there should be a lot of work written around a problem like that. All right, number 2. It says there's a picture of a decagon. I am terrible at drawing decagons, so I hesitate to even try. So I'm just going to draw the part of the hexagon that I need. So just pretend that there's this hexagon. Pretend it's all pretty, it's complete. It says that the side is 6. This time they gave us a side and not a radius. Okay, so I write down my formula. Area equals 1/2 perimeter times apothem. Now, on this problem, since they gave us a side, we can find the perimeter pretty easily. Each side is 6, and there are 10 of them. There are 10 of these sides in a decagon, and so that is 60. That's the perimeter. Perimeter is 6 times 10 sides. And now I need the apothem. Okay, the apothem is what I don't have. So I'm going to draw in that triangle. And I'm going to draw in that apothem. And what happened to the 6 is that became a 3 and a 3. So this is a 3. And I'm going to draw that little half triangle because I want a right triangle. If you don't have a right triangle, you can't use all that stuff from chapter 8 to find missing parts. So that 3 moved down here. I'm looking for this. I'm going to call it A for apothem. Or you can call it Y. Or some other variable. Okay, let's talk angles. That central angle is 360 divided by 10 because it's a decagon, and you get 36 degrees. And then when you drew in that apothem, that 36 got cut in half, so this is 18 degrees. Now, 18 degrees is not special. It's not 30 or 60 or 45. So the only way to get this missing value A is to use trigonometry. So in relation to this angle right there, this is the opposite side. This is the adjacent side. So this triangle problem right here is a tangent problem. So you write tangent. Tangent of 18 degrees is equal to opposite over adjacent. And since the variable's on the bottom, you divide. So you grab a calculator and you do 3 divide by tangent 18. Oops. 3 divide by tangent 18. You get this ugly number. Now, I would not round this to 9 because that's just rounding too far, and so your answer is going to be a little bit off. If you do round to 9, you get it right, just round it a little too far, so your answer may not match what the book says. So 9.2331 is what I'm going to put. 9.2331. It's pretty standard to round these little inner measures that you're finding, not the final answer, but these little measures that you're going to wind up plugging in to 4 decimal places. That's typically what mathematicians do when they write a key to the book. Okay, so here's what I just found. I found that measure. And that measure is the apothem, which needs to go in this formula, 9.2331. And since it's still in my calculator screen, I'm just going to leave it in there, and I'm going to multiply that by half of 60. Half of 60 is 30, so I'm multiplying that by 30. And you get, this is about 277. So if they had asked you to round to the 10th place, that 9 would round that up to a 10. So we're going to have to carry that rounding to this. So 277. Approximately 277 centimeters squared. Okay, number 3. Number 3 is that funky little bonus formula they had on the back of these notes. If you have a triangle with 2 sides and the angle between them like this, if you have side angle side, you can find the area of that triangle. You can find this space right here with this formula. It's kind of like a little just bonus formula. It only applies to triangles where you have side angle side. So 1/2 B and C are just the two sides. It does not matter what order. And the angle is the, A is the angle that's between those two sides, so 56. So basically it's all the numbers they gave you in the picture. You just have to know where to put them. And then you just grab a calculator and you multiply it in that order just like it says. So 1/2 times 6 and 9 times 6 times 9 times sine of 56. Sine 56. Looks like that. And then you press equals and it does it for you. 22.4 roughly. Approximately 22.4. Let's see. I don't know if they gave y'all units here. I forgot to write them down. So if they didn't, you just put units squared. If they gave you units, you put whatever unit they gave you squared. Excuse me. All right, so that's 1, 2, and 3. Number 7 is exactly like this problem. In fact, it's the same thing. It's a decagon, and they gave you a side of 4. So if you didn't know how to do it, maybe after seeing this one worked out, you might want to try it again. That might help. And then number 15 is just like this one, except that I think this is a decimal number. Or no, it's a fraction. And that's okay. You just plug in a fraction, use the fraction key on your calculator. Unless you want to practice multiplying fractions, which you can do without a calculator if you want. Okay, number 25. 25. 25 is an octagon. So octagon is about the last one I can draw. Any more than 8 sides, and my picture starts to look relatively hideous. So it looks roughly like that. It's like a stop sign. They gave us a radius, so that means this is one of those, the hardest type. I think this is 10 meters if I'm reading my writing well. Okay, so this is the hardest type because they didn't give us a side to get perimeter, and they didn't give us apothem, so we have to find all that stuff. Write down 1/2 perimeter times apothem. Okay, so I'm gonna start by drawing in that triangle. I'm looking for the apothem. That's what I want. I want this line right here. So moving that right triangle. And remember, the reason I need right triangles is because that's what allows me to use trig or special right triangles to find missing values. In an octagon, this whole central angle, 360 divided by 8, is 45. But that's, remember, the whole central angle. When you draw the apothem in there, it splits the 45 in half. So this is 22.5 degrees. That's what this angle is. And I need both of these things. I need apothem, I'm gonna call it A, and I need this little half side right here so that I can find out how long the side is so that I can multiply it by 8 to get perimeter. I'm gonna call that X. All right, to get X, I'm going to use this angle, which is not special. It's not 30 or 60 or 45, so I have to use trig. This is the opposite side. This is the hypotenuse. Opposite and hypotenuse, that's a sine problem to find X. So sine of 22.5 equals X over 10. And then to find, let's solve that. Since the variable's on the top, we're going to multiply 10 times sine of 22.5, and that gives you approximately 3.8268. Now I'm gonna work with that for a minute. What I just found is this length. And if you carry it up here to our shape, that's this little half of a side. So since that's in my calculator already, I'm going to multiply that by 2. And that gives me the whole side. This whole side is 7.6537. Okay? And since it's still in my calculator and I want perimeter, I'm going to leave it in there and multiply it by 8 to get the whole perimeter. This is the perimeter. So up here my formula, half times perimeter 61.2293. That's perimeter. Okay, so let me go through that real quick just one more time. I needed this whole side to get perimeter. So I drew this little half triangle to get a right triangle. And then I did sine. I'm going to cover that up. I did sine because it's opposite over hypotenuse. And that gave me this little half of a side right here. And then I left it in my screen and I doubled it to get a whole side is 7.6537. And then I multiplied it by 8 to get this perimeter. And now I need this apothem right here. So I'm going to ignore the x, and I'm going to do a cosine problem. Because in relation to that angle, this is the adjacent side. This is the hypotenuse. So I'm going to do cosine. Cosine of 22.5 degrees equals a over 10. The variable is on the top again, so I'm multiplying 10 times cosine 22.5. 10 cosine 22.5. You get approximately 9.2388. 9.2388. That's my apothem. And then I just have to multiply all that. So that's already in my screen. I'm going to multiply it by 61.2293, and then I'm going to multiply that by a half. And you get this answer, approximately 282.8 meters squared. If the answer in the back of the book is different than this answer, it should be pretty close. It's possible that they rounded these to different places. They don't round too far, though. They would not round this to 61.2. They would take a few digits out. But it's possible that it's a little bit off because of rounding. And then the last one, number 27, is the word problem about the Pentagon. So it says in Washington, D.C., the Pentagon has a side that's 921 feet. Okay, so this is the problem. They want this area, the area covered by the Pentagon. So since all I have is side, when I look at my formula, perimeter times apothem, I can find perimeter pretty easily, because if one side is 921, then the whole perimeter is 921 times 5, which is 4,605. That's the perimeter. And what I need is apothem. So again, I don't have that apothem. And to get it, I'm going to have to draw this triangle. The reason I need that triangle is to get this angle so that I can split it in half when I work with this right triangle. So 360 divided by 5, I believe that is 72. So remember, that's the whole central angle. When I draw this right triangle, that central angle is split in half, so this is a 36. The 921 just got split in half. This is 460.5. And I'm looking for apothem. That is not a 30 or a 60 or a 45, so I have to use trig. This is the opposite side. This is the adjacent side. The hypotenuse is blank, so I'm using tangent. Tangent of 36 degrees is equal to opposite over adjacent. The variable's on the bottom, so you're going to divide. 460.5 divide by tangent 36. That's the apothem. The apothem is 633.8239 feet. Now, I know that's a lot to write, but that just makes it more accurate the more decimals you use. 633.8239. And then I multiply that by this and by a half. So since it's already in my screen, I'm multiplying it by 4605, and I'm multiplying that by 1/2. And you get this ugly answer, 1459379.5. They want this rounded to the nearest 1,000, which is right there. And the 3 would tell you to leave that 9 as a 9. You don't round the 9 up. So it's 1459000. Oops, comma in the wrong place. 1,459,000 feet squared. And that's a big number because it's in square feet. I mean, the Pentagon is a huge building. So if you take that number and divide it by roughly 45,000, that's about how many square feet make an acre. It's about 6.5 acres. So the Pentagon sits on about 6.5 acres. All right, so these problems are not easy. And so I hope that helps, especially if you haven't done the worksheet yet. Maybe doing a few of these will help with that worksheet. All right, bye y'all.